Okay, so I've separated the HL and the SL class. So they're doing series and sequence. So we're just HL. So we're gonna start chapter 3, but a little backstory, and we're gonna talk about things you might need for your more advanced math classes, but we're just gonna talk about it. So I just want to talk about. We'll get there. We'll get where we're going. Question: what does it mean when we say that P is divisible by Q? What does it mean when we say P is divisible by Q, right? What does that mean when we say that P is divisible by Q? It means that P is equal to A times Q plus 0, right? So if it's not divisible, if P is not divisible by Q, then we say that P equals A times Q plus some R, which is the remainder. Now, you've done this, you know. So, yeah. And if R is 0, it is divisible by, yeah. If R equals 0, then P is divisible by Q. We say that Q is a factor of P, right? Is 2 a factor of 17? And you say, no, Mr. Adler, because 17 equals 2 times 8 plus 1. Because there's a remainder, 17 is not divisible by 2, and therefore 2 is not a factor of 17. Is 5 a factor of 20? Is 5 a factor of 20? And what do you think? Say, yeah, yes. Because 20 equals 4 times 5 plus 0. Right? So we're not gonna need this for anything on the math HL, but you're gonna need it for advanced math. So the question is, chapter 3 is polynomials. And we're gonna be talking about breaking polynomials down. Let's just first of all, what is a polynomial, by the way? A polynomial is, it's the sum of non-negative integer powers of x, right? Now, you've been working with polynomials before. Last year you done linear, and you also did quadratics. Maybe you did cubics, I don't know, but you've definitely. So basically, we say P of x is equal to A of 0 x to the n plus A of 1 x to the n minus 1 plus A of 2 x to the n minus 2 dot 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 A of n. So we organize, or we classify polynomials based on the highest power, and we call it the order of the polynomial. So the order of the polynomial of P of x is the highest exponent, highest power, or n, right? And yes, the highest power, right? And so let's see, a couple other things. You might have known that, if this is like A of 0 is the lead coefficients. These A zeros, these are known as the coefficients. You've studied that. A0 is known as the lead coefficient. And we're going to see, it's just interesting, if A0 is positive, we say it's a positive polynomial. Polynomial. And you're going to see that in this case, it's like the slope or like the smile in a parabola. We're going to see that this is going to result in a cubic that goes off to positive infinity, or we're going to see it's a quartic that goes off to positive infinity. If the lead coefficient of your polynomial is negative, then we have a negative polynomial. And you know what? Because I'm lazy, I'm just going to do this in red, right? A negative polynomial, that's negative slope. That's a frown. That's, a curve that goes off to negative infinity, or same here. So these are the negative polynomials. Small little thing. Two polynomials are equal if they have the same order and the same coefficients. And the coefficients are equal, right? So we want to move to the idea. So why did I bring factoring up, and then why did I talk about polynomials? Well, you've been breaking down polynomials. So the question is, so the idea is we want to factor polynomials. We want to see if polynomials have the same behavior as regular numbers. The question is why? Why do we want to teach this? Who cares? Well, the idea is you want to find your zeros. And you've been doing this you did this last year. You did it with linears. You set the equation equal to 0, and it was easy. To find the zeros of quadratics, you need to factor it, and you got really good at it. The question is, can we factor polynomials of order greater than 2? And we're going to need this. We're going to need factoring. Factoring is going to be really important. Not only do we find the zeros, but in next year, or maybe at the end of this year, we're going to talk about taking the derivative. And when we set that equal to 0, we can actually find when the curve reaches maximums and minimums. So this is a really important skill for us. So the question is, our main question today is, is there a fast way to find the factors of a polynomial? So the book goes through 3A, 3B kind of goes through a lot of old school grunt work. And so the question is x minus 1 a factor of x to the 4th plus 3x squared plus 2x minus 6. Now, you can go to Desmos right now, stick this in there, and you can see whether or not it passes through the x-axis at 1. But we want to know if we can do this by hand. Now, let me go through real old school. You can fast forward through this, or you can watch. Really old school says, you know what? Do like that long division you did. So x minus 1 into x to the 4th plus 3x squared plus 2x minus 6. How are we doing for time? Hold on a second. Do I have a class at 10 o'clock? No, it starts at 10:15. I'm good. And so you'd say, okay, well, I need to get that x to the 4th, so I multiply this by x to the 3rd. I have x to the 4th minus x to the 3rd. And then you subtract this, and you have x to the 3rd plus 3x squared plus 2x minus 6. Oh no, you don't bring it down. Next, we're going to multiply this by x squared. So we have x to the third minus x squared. We're going to subtract it. Remember old school division? This is why we taught you this in 5th grade. So x to the third minus x to the third is 0. 3x squared minus x squared is 4x squared. Bring down the 2x. Multiply plus 4x. We have 4x squared minus 4x. Subtract these. 4x squared minus 4x squared equals 0. 2x minus negative 4x is 6x. Bring down the minus 6x. Plus 6. You do 6x squared minus 6. So, old school. Yes, we would write x to the fourth. So we say yes, x minus 1 is a factor of x to the fourth plus 3x squared plus 2x minus 6. And once again, I'm not making you do this. You can fast forward for this. We would write, can you see down here? Yeah, you can. We would say that x to the fourth plus 3x squared plus 2x minus 6 is equal to, ready? X minus 1 times x to the third plus x squared plus 4x plus 6. Really old school. Next. So what does the book do? Well, the book's kind of old school also. It's going to take me 5 minutes before I get to the trick, so you might want to fast forward. The next trick, ready? This is a little less old school. We're getting a little closer. And some of you might like these methods, and you might need these for something in the future. I took a course last summer with complex analysis, and I needed the next thing. Is x plus 1 a factor of x to the fourth plus 3x plus 2x minus 7? This is A. Okay, next, also old school. If it is, then, right, if yes, and once again, you can fast forward through this. If yes, then, ready, right, we know that x times something to x to the third gives me my fourth. So then x minus 1 times ax to the third plus bx squared plus cx plus d is equal to x to the fourth plus 3x squared plus 2x minus 6. You know where I'm going with this. Do major bear claw. Once again, I'm not making you do this, but I'm just showing you all the old school methods. They're saying, fine, ax to the fourth plus bx to the third plus cx squared plus dx, right, ready, minus ax to the third minus bx squared minus cx minus d is equal to what? X to the fourth plus 3x squared plus 2x minus 6. Still old school, but bear with me. Well, you can kind of get some idea here. You can say, hey, Mr. Adler, you said that if two polynomials are equal, sorry, let me get some water. You said if two polynomials are equal, then their orders are the same and all the coefficients are the same. So we can work backwards. So you're like, okay, well, negative d equals negative 6. Where's my red pen? There it is. Negative d equals negative 6, which means that d equals 6, which we got over there. Nice. What's going on with the x coefficients? Well, that means that d minus c equals 2. Well, we know that d is 6. 6 minus c is 2. C is 4. Nice. Let's keep going. C minus b, the x squared coefficients correspond with the 3. Well, we know C C is 4, so C minus B is 3, B is 1. Nice. What's going on with the cubes? Let's see. We know that it should be 0, right? Let's see if we got this right. What's A, by the way? Actually, no, let's keep going. What's B minus A? Well, there is no x cubed term. It's 0. That's what I remember. Technically, always remember what's here. Always, what's here? You go, actually, Mr. Rowler, there's a 0, x cubed. We don't put it in because we cancel out, but it is there. Always, we're going to need that. B minus A is 0. 1 minus A is 0. A is 1. And yeah, that works out. Nice. Okay, let's get a little more modern. Is x minus 1 a factor of x to the 4th plus 3x squared plus 2x minus 6? The next method we can use, you'll like this a little better, is called the remainder theorem. And it goes something like this. Let p of x be a polynomial. Right? Or like a function, right? You're going to plug some x value in. If x minus a is a factor of p of x, then, this is kind of cool, then p of a equals 0. What they're saying is take the factor, no, they leave it like this, so you know what? Let's change this factor. Let's go all out. Let's change the factor to, let's change this. Let's change the factor to ax minus b, right? So what you're going to do is first set that equal to 0, solve for x, and once again, if ax minus b is a factor of this polynomial, then p of b over a should equal 0. If it doesn't equal 0, it's not a factor, and it gives you the remainder. It doesn't give you the polynomial that we almost got. That's going to be the next method. Well, let's test this out. Let me see if I have some examples here. I do. Is it a factor? Well, let's see. Let's use our example. We know that x minus 1 equals 0, so x equals 1. P of 1 is equal to, I'm plugging it in here. So I have, it's 1 to the 4th plus 3 times 1 squared plus 2 times 1 minus 6. Is that 0? 1 plus 3 plus 2 minus 6? Yeah, that equals 0. So the remainder theorem tells me if it's a factor, it just doesn't tell me what the polynomial is. Let's try some more examples. Is x minus 2 a factor of x to the 3rd plus 3x squared minus 5x minus 10? Is x minus 2 a factor of x to the 3rd plus 3x squared minus 5x minus 10? Well, you know what? I don't want to do long division. I don't want to do that whole back and forth. I just want to know if it's a factor. Say, fine, first, set x equals 2 to 0. So x equals 2, and then stick it in the polynomial. Let's see. 2 cubed plus 3 times 2 squared minus 5 times 2 minus 10. What is this? You have to know how to do this for part 1 without a calculator, right? Because this is not difficult. 8 plus 12 minus 10 minus 10. 20 minus 20. Yeah, it's 0. That's a factor. doesn't give us like what the other breakdown is. We know it's linear times quadratic. Sorry. 1, 2, 3. We know it's linear times quadratic gives me a cubic. We know that. I just don't know what that quadratic is. Is 2x minus 3 a factor of x cubed minus 2x squared minus x plus 3? What do you think? Try it on your own. Once again, set this equal to 0. Put that number, that root, inside the polynomial. Okay, we're back. 2x minus 3 equals 0. X equals 3 over 2. Let's stick this in here. P of 3 over 2 is... Can I speed it up? Are you going to hate me for that? Too bad. 27 over 8 minus 18 over 4 minus 3 over 2 plus, you know what? I'm skipping ahead. 24 over 8. Because I'm not afraid of fractions because I'm in higher level math. What's going on over here? Let's see. 36 over 8. What's going on over 12 over 8? Is this 0? Is that 0? No, because I just can see it. 27 plus 36 plus 12 minus plus 24. This is not 0. I'm not sure what it is. I don't have the time and I don't care. The question was, is it a factor? The answer is no. Okay. Now I'm going to wait till the next video.